Today we are going to discuss lens topic, thin lenses in contact, the topic name. Generally, if two or more lenses are in contact, then how to find the focal length of the system, and there will be some object distance they will provide you, and how to find the image distance and what is the nature of image, how much power the optical system, how much power the system will have, everything we can see in this class. Okay, so the topic name chapter is ray optics, it is, and the topic is thin lenses in contact. Thin lenses in contact. Okay, so thin lenses in contact means like there will be some lenses, some number of lenses, they will be in contact again. Okay, so this may be lens 1 and lens 2 and so on. There may be n lenses. Okay, the focal length of this first one is f1, second is f2 and so on, nth lens is fn, and the power of first one is p1, second is p2 and so on, the power of nth is pn. And they will say that they will give you the data that there is an object O at a distance u meters from the first lens. Okay, then where will be the image? So it's very, very simple. If you think, the image due to first lens will be object for the second one, the image due to second lens will be object for the third one, and so on. The image due to n-1 lens will be object for the nth one, and final image due to the nth lens will be formed. Okay, let the final image distance is v and object distance is u, and lens formula is 1 by v minus 1 by u equals to what? 1 by f. What is this f? Actually the focal length of the system. This system's focal length we can easily find. So before going to find the focal length, better we can see first power of the system. The power of the system is additive. Remember, the optical power is additive. If it is positive, we can add. If it is negative, we can subtract it. I'll tell you when it is positive and negative also, right? So P1 is the power of first lens, P2 is the second lens power, and so on. Okay, so if you see that power of lens, you know that the power of lens is equals to what? Reciprocal of the focal length of the lens. So total power is nothing but 1 by the total focal length of the system equals to 1 by f1 plus 1 by f2 and so on, 1 by fn. Okay, so these are the two formula which are very, very important. They can ask you the questions based on this. Okay, once you calculate this, and you can substitute here in the formula and you can find the answer. And let me tell you what is the meaning of this again. Okay, so suppose you got power, you have calculated the power P, and mathematically there are three possibilities that you can have here. The power may be greater than 0 you may get, or maybe equals to 0, or maybe less than 0 also sometimes you will get. Okay, suppose you got positive power, it means that the total system is behaving as a convex lens, okay, or convergent system. Okay, if you got the total power as positive, then the total system is behaving as converging lens. Okay, converging lens is nothing but convex lens. Okay, if you got negative power, then the total system is behaving as a diverging lens. Diverging lens is also called as concave lens. Okay, and in the third case, if the power is 0 you got, that is the power 0, which means that it is just a glass plate. It is no lensing, there is no lens. Effectively there is no lens, meaning that the total, one of the lens is cancelling the other lens. Like for example, there are two lenses and the total power you got 0. Then for power of the first lens is cancelling the power of the second lens. Okay, so that is what happening here. The total system neutralize so that a parallel beam will go again a parallel beam. Okay, here it will be happening. Like there may be, getting narrowed or widening. Okay, it may happen there, but a parallel beam incident and it will go as a parallel beam only. Okay, it will not converge or diverge. But coming to this first case, a parallel beam incident, then on the system, then it will be converged. After refracting from the system, it will be converged. And coming to this case, an incident beam is parallel. After incidenting here, it will be diverged. Okay, so that is what the power positive, negative and 0. Okay, and how to find the power is very simple. Sum of the individual powers. And how to find the focal length? The sum of the reciprocals of the focal lengths. Okay, so let us consider an example here so that you can easily calculate, you can easily understand. Okay, so example, suppose there is a convex lens and a concave lens. Okay, the convex lens focal length say 30 centimeters and a concave lens focal length say it is 40 centimeters. Okay, and in front of the convex lens at a distance say 20 centimeters there is an object placed. Then where will be the image formed and what will be the image distance, of course, and nature of the image also they can ask you. So we can solve this problem by using this condition. So they said the focal length of convex is 30. So according to the formula, 1 by f is 1 by f1 plus 1 by f2. But here concave lens focal length they given 40, but we should consider minus 40 because it is a divergent lens. Okay, so 1 by 30, this is 30 minus 1 by 40. So it will come 40 minus 30 divided by 1200. Of course it is 1 by 120, that is 1 by f. So you got the 1 by f is nothing but power. Okay, so power you got positive number, so it is going to behave as a converging lens. Okay, so how much the focal length of that? It is f equals to 120 centimeters. But now the object distance is how much they given? Just 20 centimeters. Then you can apply in the lens formula 1 by v minus 1 by u equals to 1 by f, where f is this 120. We need to find this v, and minus 1 by u is 20, but we should take minus 20 because it is a real object. It is equals to 1 by 120. Okay, so in this minus into minus will be plus, and again it will be 1 by v is equals to 1 by, trust me, it will minus 24 centimeters. Okay, so what is this minus meaning here? The image is virtual image. Virtual image. Okay, and it is going to be behind the object. Okay, so magnification also you can find. The magnification equals to v by u, which is minus 24 by minus 20, which is 1.2. Okay, it should be positive magnification because it is a virtual image. Okay, so this is a particular example we can have. I can generalize here the topic, I mean for this problem topic. Okay, so if there is a convex lens and a concave lens of focal length f1 and f2, this combination we call it as achromatic doublet. Okay, achromatic doublet, and effective focal length is 1 by f equals to 1 by f1 minus 1 by f2, because f2 is negative. Okay, and we can say otherwise the power p equals to p1 minus p2. Now we can have the conditions here, whether system will behave as convergent lens or divergent lens. If p1 is greater than p2 or f1 is less than f2, I mean convergent lens focal length is less than the divergent lens focal length, then the system will behave as convergent lens. Okay, other case, if p1 is less than p2, that means what? The power of convergent lens is less than the power of divergent lens. Then what was the condition? Focal length is greater than the this one, or the f1 is greater than f2. In this case, the system will behave as divergent system. I mean the effective lens is going to be a divergent lens. Okay, and you may get a doubt here, what if p1 and equals to p2, p1 and p2 are equal? Then the net power will be 0, so one will cancel the other. Okay, that would happen. And I told you already, this system is called as achromatic doublet. Achromatic doublet, and this word you will see in case of aberration, in that chromatic aberration. Okay, I hope you got it. So let us generalize what I discussed here. Suppose there are n lenses in contact, lens 1, lens 2, lens 3 and so on, nth lens. Okay, there may be concave lens also. Okay, there is no restriction that always convex lens will be there. So this power is P1, P2, P3, P4 and so on, Pn. Then total power equals to P1 plus P2 plus P3. Here P4 should be negative, and so on. It is Pn. The effective focal length is 1 by f is equals to 1 by f1 plus 1 by f2 plus 1 by f3 minus 1 by f4 plus and so on 1 by fn. And overall magnification, the magnification due to the first lens is going to be m1, for example, due to this m2 and so on. Then overall magnification is m1 into m2 into m3 and so on mn. Okay, magnification you have to multiply the magnification of each lens, you have to multiply with each other, so that you will get the final magnification. Okay, and here one more special case will be there. If there are only two lenses of focal length f1 and f2, and they are separated by a distance small d, or the power of the lens is P1 and P2, then the total power here is going to be P equals to P1 plus P2 minus D into P1 P2. Okay, so this is the formula. Okay, I hope you got it. Let us discuss a problem based on the discussed model, okay, previous model. And this is the problem I have already written here. There are two convex lenses which are in contact. The gap between the lenses is filled with a liquid. The liquid's refractive index they will provide for us. The liquid's refractive index here it is 1.3. The focal length of this lens is 30 centimeters and the focal length of this one is 70 centimeters. Okay, and in front of this system at a distance 90 centimeters there is an object is placed, that is real object. And the question is, for this object where will be the image? Okay, so very simple formula we can apply, 1 by v minus 1 by u, which is 1 by f. Here u is minus 90, v is we need to find, f we don't know that. Okay, so to find that f value we should use the concept that is thin lenses in contact, that is equals to 1 by f is equals to 1 by f1 plus 1 by f2 plus again 1 by f3. Okay, here the liquid which is in between the two lenses is going to behave as a one more lens, that is going to be liquid lens. Okay, so the focal length of the liquid lens is f3, that we need to calculate, because f1 f2 values they mentioned already. So focal length of the liquid lens we need to calculate. So if you draw the liquid lens, this is the liquid lens. Okay, and this side is R1 and this side is R2. If you consider the sign convention of concave lens, it is minus R1 and it is going to be plus R2. Okay, how to find R1 and R2 values? That's very simple. You have to depend on the lens maker's formula. The lens maker's formula is 1 by f is equals to mu minus 1 into 1 by R1 minus 1 by R2. For first lens, if you apply this equation, that is 1 by 30 is equals to mu minus 1, or you can directly apply the formula, that is for equiconvex lens, the focal length formula directly you can have, okay, for equiconvex lens. Okay, for any equiconvex lens, the focal length formula 1 by f is equals to 2 times mu minus 1 divided by r. So here if you take f as 30 centimeters, that is 1 by 30 is equals to 2 times refractive index of the glass is 3 by 2 minus 1 by R1 we need to find. Okay, that is what this R1. And you may find that R1 will be 30 centimeters. And the same formula we can apply for the second lens and find the R2 also. R2 will be equals to 70 centimeters because the focal length of second is 70. Now to find the focal length of this liquid lens, again we have to use the same formula, but the mu you have to take the liquid's mu. Okay, so the same formula, if you take 1 by f3 will be mu for liquid 1.3 minus 1 into 1 by R1, that is 1 by minus 30. Why minus 30? Because it is going to be sign convention with that, and it is minus 1 by 70. Okay, this minus is there in the formula itself. Solving this will be 3 by 10, that is 0.3 into minus 70 minus 30, it is going to be minus 100 divided by 2100, it's gone. Then it is going to be 3 sevens, so 70. So f3 is going to be minus as it is here, so minus 70 centimeters. Is that clear? Then we can say the total focal length in this formula you can find, you can apply 1 by f is equals to 1 by 30 plus 1 by 70 minus 1 by 70. That's 70, this one. Okay, and it is cancelled. And effective focal length is how much we got? Just 30 centimeters. Okay, you can substitute here 1 by v minus 1 by minus 90. What is u here? Object distance, which they given already, 90 centimeters, but it is a real object, so minus 90 equals to 1 by 30. Then we can say, we can have this one, 1 by v is equals to 1 by 30 minus 1 by 90. So it is plus 60 divided by 2700. So 270 by 6 will be the image distance. So 270 by 6 will be some number, that is 3 2s are 390, so 45 centimeters. Okay, so 370 by 6 is going to be 45 centimeters, and you got positive distance. Okay, so positive distance means what kind of image it is going to be? Positive distance means it is going to be real image. And we can say here itself the total focal length is positive you got, so this total system is going to be convergent lens. Okay, I hope you got it. Thank you.